Now we're going to talk about probability where we have mutual events, meaning you have something happen, but it has two different characteristics possible. So when we're talking about compound events, we're talking about two different events happening. Now we're just talking about one event, but it has two characteristics. So we look at mutually exclusive. So an example of mutually exclusive would be even numbers and odd numbers. There are no numbers that are both even and odd. So they're mutually exclusive. Now let's say we're looking at the numbers 1 through 10. So if I'm looking at the probability of A or B, I'm going to say what's the probability of A plus the probability of B. Now you notice in yellow here underneath I put this, the word or can also be replaced with the symbol for union. So we're talking about A union B. So when we're putting them together, we're not excluding anything, we're including both. It's called a union. Okay, so we look at the probability of A plus the probability of B. Now if we look at this specific example, the probability, let's say we'll find the probability of even or odd. So what's the probability it's even plus the probability it's odd? And if we look into that a little bit more, the probability it's even, so if I look at the numbers 1 through 10, I've got 5 of them that are even out of 10. And the probability it's odd would be 5 out of 10 also. And when I add those together, I get 10 out of 10. So the probability it's even or odd is going to be 100% or 1. Okay, but if I look at the and part, think about it. If I think about an and, or you notice that this other little bit here, this is an intersect, meaning only the parts they are both in common. So I'm looking at what number is both even and odd, and hopefully you realize that there are none. And so no matter what, when you're working with mutually exclusive, there is no such thing as even and odd, or there is no such thing as an and in mutually exclusive. And that's what mutually exclusive means. They have nothing in common. There is no object or thing that has both characteristics. So that's mutually exclusive. Now it gets a little more complicated when we're looking at overlapping events, because overlapping events are events where they actually do have something in common. There are some that have the same thing. So let's say we're going to look at an example where we have the numbers 1 through 10 again, but here we have even ones, and over here we have multiples of 3. So I'm going to use a Venn diagram to help me to sketch this out so I can count easier. So let's see, 1 is neither even nor a multiple of 3, so I'm going to put it outside in the universe. 2 is even, 3 is a multiple of 3, 4 is even, 5 is outside, 6 is both even and a multiple of 3, so it goes in here in the intersection. 7 is outside, 8 is even, 9 is a multiple of 3, and 10 is even. Okay, so we have overlapping. We have our numbers in the even, that includes a 6. We have our numbers in the multiplication or multiple of 3, that includes a 6. And then we also have this section where it's both even and a multiple of 3. And so when I'm looking at the probability of A and B, or the probability of A intersect B, when I'm looking at that, I'm going to figure out by looking at it and knowing how many are in both, and I have 1 out of the 10 numbers. So the probability of A intersect B is 1. Now if we look at the probability A or B, okay, so what's the probability it's even or a multiple of 3? Well, then I want to look at, if I take, just like before, it says or, so I'm going to add, if I take the probability it's even plus the probability it's a multiple of 3, I have a problem. The probability it's even is, let's see here, 1, 2, 3, 4, 5, so 5 out of 10, plus the probability it's multiple of 3 is 1, 2, 3, so I've got 3 out of 10, and that would give me 8 out of 10. Unfortunately, that's not right, because if I count both circles here, I've got 1, 2, 3, 4, 5, 6, 7. That's too many. 8 out of 10 is too many. So what's going on is this 6 here got counted twice. It got counted when I counted up all the evens. It got counted when I counted up all the multiples of 3. So what we need to do is when we're doing this formula, we also need to take away the probability of it's even and a multiple of 3. So we're going to take away the probability it's even and a multiple of 3, which would be 1 out of 10. So 5 plus 3 is 8, minus 1 is 7 out of 10, which is what it's supposed to be. So this is a little bit more complicated because we take and add the two events together, but then we also have to subtract the intersection. And that's when you have overlapping events because we've counted that one too many times, so we got to take it out once.